Jake, how about you? Okay.
Yeah, and a half, you're my favorite. Love you too. That is pretty whack. Yeah. Are you bored? Can you make me a slideshow of cabinets of natural curiosities?
Are you serious? What?
I Googled cabinets of natural curiosities. And I got some of these. And I want some that look really dope. Like that one.
There's one at the Museum of Natural History.
Yeah.
I want maybe 6 or 8 slideshows of what people have in different interesting ones. Black background, PowerPoint, yeah. Probably keynote on my computer. Feel me?
Yeah, I don't want to.
Too bad.
Cause can I not?
No, you have to.
Okay.
You get bored in the day.
That's what I get for saying I'm bored.
All right, Theodore. Whoa, yeah. Wonder about that. All right. A couple of quick announcements while you finish this digitalia. You've warmed up and we've stamped, and we have an after-school environmental film tonight at 6, and tomorrow at 6. Do we not have keynote?
When do you want me to go to?
We don't have keynote?
I don't know what that is.
It's like PowerPoint, but the Apple version. Do you have some kind of PowerPoint on your own?
No.
You can use Google Slides on the interweb. All right. Movie tonight and tomorrow, 6 p.m. here. It's short. Your post lab is due Tuesday next week. I hope everybody remembered that. Tuesday next week. We have a field trip next Monday. The paper for that field trip is due this Friday. You are period 3. Tomorrow we don't see each other, but somehow you're still responsible for the content of tomorrow's lecture. You can come to my period 5, my period 2, or my period 4, and you can turn in your endangered species assignment this Friday. What, Georgia?
Do you have a warm-up?
Guess so. Yeah. Yeah. If I knew what it was, I would tell you, but I don't know what it's going to be. Yeah.
I think I'm actually testing in this room. Will that change anything?
Ooh. No, because we're just going to be testing, not doing class.
How do you know that?
Because he's got a game together. Because he's not living under a rock, Georgia.
Ooh.
Wait, what?
Yeah,
Georgia.
You got a number like last week.
Okay, I didn't understand.
Georgia.
I was there right next to me. Oh, shit.
Nope. When you're flailing, it's depressing. Yeah.
And Miss Anderson
I
too.
just don't know where to go.
Yeah, wait, what are some news doing?
Let's go home.
Yeah, totally, because that happens all the time, right? The school just lets you go home. All right, first of all, we are your legal custodian during the school day. So even if the school burns down, you can't go home. I know. That's like the crazy thought. Like, that is the ragged edge of this law. That if the school's on fire, we have to keep you in a little pod, all like cordoned off and know where you are because we're still responsible for you. We can pull off an impromptu field trip if we have to, but we can never let you go home. So I don't know where you're supposed to go. But seniors must have some place where they're supposed to be. I just don't know what that is.
The auditorium.
Hey, there's somebody who hasn't been living under a rock.
Ooh.
Oh, wow.
So I don't know. I think like
you
senior
guys had a
classes
bush
might
video?
continue with senior
Okay.
classes.
Yeah, second period.
Claire, is your 1 and 3 classes all seniors?
My one, yeah, and then third period is this.
My assumption would be that your first period class will just be your regular first period class, and then during period 3, you should probably go to the library or auditorium or something.
Okay.
Obviously, you're not going to be missing out on instruction,
Yes.
but somewhere your attendance has to be registered by an adult who's supervising you. Like when I take attendance, I'm just saying that I'm legally responsible for you for that hour. Yeah.
And for seminar?
I'm going to assume the same, but
Okay.
I really don't know. Okay, I'm sorry that I don't know where you're all supposed to go. I do know where I'm supposed to be. I'll be giving out that test here tomorrow. So you can turn in your endangered species assignment on Friday, and you can come into my period 5, my period 2, my period 4, or watch the YouTube video. But you can't wear earbuds. Like that. We already finished the biome. It's beautiful. So I'd like to talk about all these photographs by these paintings by Alberta Seba that you didn't send me. That's okay. Kids in other periods did. And I have my own collection too. I'm just curious to see which ones stand out to my high school kids. Am I live with her? Look at that one. That's a weird one. And look at that. That's kind of a beautiful one. I don't know what's up with that one.
It's like a hydra.
It does look like a hydra. But most of his drawings were of stuff that's actually like real. Although he did make some weird arrangements. As he got older, he started to do like layouts. But most of them were of real stuff, even though sometimes he couldn't get the details right. So that's like a sloth.
I think I sent you that.
But a lot of the kids noticed the same ones, the marsupial ones. That's nice. It's dark at the bottom of the ocean. Stop tickling me. Is that eating a mango? Rascal. Stop tickling me. Stop it. No more tickles. And there's a weird sloth again. The most chilled out anteater. Cool snakes. There's a reason I'm showing this to you. I found out about this when someone gave me this really, really expensive book. It's called The Cabinets of Natural Curiosities, and it's a collection of this guy's paintings. Most of you already saw, he made a lot of these that had like a whole cluster of stuff on them. Sometimes from the same part of the world. There's a reason they come from the same part of the world. I have this book, super majestic, I love it. It has these huge prints. So the one with the 2 squids on it, anybody got that? This one with the 2 squids, I had that on my wall for a while. Some of them are like totally wrong. This is the picture of him that's in that book. I don't know if that's really what he looks like or not. But check out like the powdered wig and like the weird robes. And you see the background over here? All those jars. I want to tell you a story about the early sciences. Imagine the beginning of the colonial times. So, anybody know when the Europeans started sailing to colonize distant lands? 1500s? What? 1600s, something like that? Okay. So I'm not really clear on the dates. Seems like you're not either, so I could just make it up and you wouldn't know. in the year 1517, Europeans started colonizing distant lands. Funny little detail that didn't hit me until I was a grown-up. Most European civilizations, modern European civilizations, had a pretty small ecological sample to work with. Not a whole lot around. I believe the European islands have like one snake. Maybe no snakes? Sorry, I mean the English islands. I don't know what it's English islands. Ecologically, you know, Europe is pretty dull. Imagine somebody gets back from some expedition and they're like, hey, I just went to this place that we're going to call Africa now. And man, you know, down there were these like giant bald plated cows with like huge spearhead points. Like, oh, that sounds pretty neat. I wish I could see that. The guy gets back from Africa and is like, oh, there was these like gigantic, super tall spotted horses with long necks and weird little horns. Like, wow, I wish I could see that. It's a 40-foot tall horse, man. Long, skinny legs, yellow with brown spots. You know, there was no internet, there was no cameras, there was no television, there was no documentaries. And people started to show up with stories of crazy things that they had seen. People like me, we would just be curious to hear about it. We would pay to go see a guest speaker. She would come from like some trip, and she would stand in front of an auditorium and just tell stories. I saw these big pink birds that were like long-legged and were all drinking. They had these weird bills that drank stuff from upside down. And I saw these giant bats that suck your blood. People would be like, oh. But people who were really wealthy, they could do one better. They would pay a hunter to go and shoot stuff and bring it back.
Or would they just pay to go to the place?
Well, because it would be very expensive and dangerous. You didn't have good chances of coming back, right? Like 6 years out of your life to go cruise around South America and maybe come back. Like, I don't know, man. I'm just going to stick around and keep running my business and keep getting rich, but I'm going to pay him to go out there and shoot stuff. How many of you have heard of Charlie Darwin? Right, everybody? So, homeboy went out there as a hunter, basically. He went out to build a collection for a rich person. His spot on the Beagle was sponsored by a wealthy family, friends of his uncle or grandfather or something. And they sent him with like a barrel, like a wooden barrel of lead pellets. The number is like really debatable, and I'm not really an expert on this, but I've heard he shot something like 126,000 birds. Charlie Darwin, during his voyage of the Beagle, got bullied a lot because he was really frail, and like all the burly seamen would make fun of him because he was like wimpy and weakling, and so he would like get off the boat as soon as possible and row around shooting stuff. Charlie Darwin has probably eaten the most bird species of any human being ever. Because like he would shoot them and then be like, I got 2 flamingos, only need to take back 1, so he like ate flamingo. His favorite bird was the South American equivalent of an ostrich. He said it's the most delicious meat. Charlie Darwin killed something like, I don't even know, 16,000 different reptiles and brought them all in jars. He went down there to collect stuff. Imagine what happens when Charlie Darwin gets back to England. He goes, okay, yeah, thanks. I had a lot of fun working for you the last 6 years. All your dead stuff is in those 15 cases on the Beagle. We'll have it delivered to your house. Thank you. Leah's making me a slideshow of this. But back in the day, wealthy people would build these things called cabinets of natural curiosities. And nowadays, we collect the leftovers from those collections. You know, like powdered wig, frilly collar, silk robes, women with like the dresses and the like corsets and stuff, and the little tippy hats. They would like have high society parties where people would meet around a huge dining table. They would eat like an exotic dinner of like usually some foreign meat that was supposedly still fresh or hopefully still edible from distant lands. They would clear the table and they would be like, and now my distinguished guests, I will open my cabinet of birds shot in South America. And they would bring out these like stuffed birds. And imagine how exciting that would be at a time when people heard stories of a new world and you were the lucky, privileged few to actually see these birds with your own eyes. Right? The science of learning our planet was driven primarily by wealth, boredom, curiosity. People would have these parties and they would open their cabinets of natural curiosities. People would just collect stuff, like, oh, I've got all these like stuffed, you know, like the pin butterflies, you know, like that's a leftover of this habit. Skulls, stuffed animals, seashells. Whoa, creepy. That was all human stuff. Imagine if this was like your room. Oh man, I can't go to that one. Oh, there it is. Like, I'd invite people over to come party at my house. Like, check it out, they got like some stuffed geese up there.
Whoa.
Alligator.
Pretty sure I see a human head.
Hammerhead shark.
Shit,
Yeah, you know, like we recognize those as humans now, but back then we would just call them, you know, people of color, whatever. Human-like.
What?
Yeah, no, like there are people whose cabinets of curiosities had like what we would obviously consider to be people, right? But other people were like, I don't know, that's not people, I don't speak English. Yeah. Creepy times. Creepy times. Okay. And at that time, there was this guy named Albertus Seba who would just like get bored and he would go to his friends and be like, yo, can I hang out in your parlor for a week and paint your cool collection of stuff? And so his thing was he painted the cabinets of natural curiosity for his friends. That's why they're so often inaccurate. His paintings don't make sense. Like the face on the sloth, because he wasn't painting a living sloth. He was painting what the hunter brought back on a 3-year journey across like tropical seas. And then you would get this like badly taxidermied sloth and you kind of have to guess what the face looks like. Take out your study guide and your assignment 3.2. Can you imagine how exciting it would be to live in that first generation that got to see all that stuff? Like, information is so readily available to you that it's lost its pizzazz. But living in a world where your entire cultural history was based in a pretty boring and small ecosystem, and being alive during those couple of decades when that all just exploded with all these new species that nobody else could see, that must have been so exciting. This guy dedicated his life to painting it, and I can totally see why. I found my search image that has all his paintings on one page. Look at that. That is so cool. This guy's paintings are really beautiful. If you're trying to figure out what to ask for Christmas, you should get that book right there. Cabinet of Natural Curiosities. Alright. Assignment 3.2 is all about biogeography. It's our understanding of how life gets distributed across the planet. And today we all know it's plate tectonics and evolution. But I want to check in and make sure that everybody's good at your evolution stuff. I don't know how many of you have a background in biology. Took biology? How many of you did not take biology? Okay, how many of you have heard of natural selection? Adaptive pressure? Okay. So let's go really quickly here. Vocabulary in assignment 3.2. Ready, set, ask me now. Yeah.
Number 14.
I don't have my vocabulary terms numbered.
How is animal and plant diversity distributed?
That's not a vocabulary term, that's a question. Vocabulary, yeah?
Adaptive radiation.
Adaptive radiation is when species adapt to a bunch of new environments, or as they radiate, they adapt differently to each environment. That might be a better way to say it. As they move into new places, they adapt to the requirements of each environment. The classic example of adaptive radiation is like Darwin's finches, where one species of finch found a whole archipelago of islands, and on each island there was slightly different food sources. So over time, the birds evolved to take advantage of those opportunities, and so they adapt as they radiate. Yeah?
Biological niche.
This is a very simple and still very complicated thing to say. An ecological niche is pretty much like the job you do in an ecosystem, how you make your living. There's a lot of ways to define this term, Ryan. Some people define it very, very differently. So you could say the description of a species. Because if you're like a tall, naked ape that walks around and eats almost anything, that's also how you make your living. But that's your niche. It's like where you fit into the ecosystem or what you do within the ecosystem. Yeah?
Wallace's wrongs.
We'll talk about that a little bit later. That's your answer number 14, by the way. Other vocab? Yeah?
Permafrost.
Permanently frozen ground. So in the tundra, underneath all that snow, the ground freezes solid.
Mm-hmm.
When it melts, just the top of the ice cube melts. The rest stays frozen underneath. That's called permafrost.
Okay.
I like that. Ask me more.
Okay, awesome.
Yeah.
Genetic
Random changes in the genetic makeup of a species.
But not caused by mutation.
Not caused by mutation, that's right, it's just random changes. This only happens in small populations, and you should write that down. Genetic drift only happens in small populations. And I'll explain why if you've already written down the small population thing. Okay. Imagine that a tall person falls off a ladder today. Does that change the average genes of humanity?
No.
Not very appreciably, right? Because there's a lot of tall ones and short ones and medium humans left. Agree? But if you have a population of 3 humans, and by coincidence, a tall one falls off the ladder, you result in a dramatic change in the genetic frequency of humans, in the genetic diversity of humans, that was purely random, that was not a mutation, and that was not for adaptive or selective reasons. Random events in a small group make big changes to the genes remaining in that group. If there's 3 humans and the redhead falls off the ladder, by coincidence, she just happens to fall. Then you can imagine that would change the frequency of genes within that gene pool, but it's random, not selective, and it's not a mutation. That's called drift. What else? Yeah?
Biological soil crusts.
Those are the crusts that develop in the desert. Did we talk about this yesterday? That like spongy stuff, the mineral crust in the topsoil of the desert. Yeah. Yep.
Genetic bottlenecks.
I think I want to treat that as a study goal at the end. Anybody else? Yeah. Symbiosis. These are species that have a close association.
Well, there's symbiosis and then there's symbiont.
A symbiont is each species within a symbiosis. So there's like ants which live at the base of a tree. That tree grows little sugar pills for the ants to eat. It's a symbiotic relationship because the ants depend on the tree and the tree depends on the ant. Whenever somebody comes over to eat the leaves, the ants will swarm the giraffe and make sure that they chase it off. So the ants protect the tree feeds the ant. Those are the 2 symbionts of that symbiosis. Other vocab. Please look at study goal number 10. In number 10, I said there's a whole list of basic evolution terms, and I said, please make sure that you know all of these. He's just grunting. I said, please make sure that you know all of these and ask me if they don't make sense. Did anybody find a vocabulary term in evolution that they wanted to ask me about? So I want to try a really, really, really quick thing about evolution, if you don't mind. You should know that evolution acts on existing variation. It's important that you know that. Evolution doesn't make new answers. People always say, why haven't we evolved to have X-ray vision or to fly? Both of those things would be awesome. But that doesn't mean that they have to happen. Evolution is not a creative force. It is a selective force. So the answer to how did fill in the blank evolve is always the same. Someone had more babies than the other one. So how did you evolve an immunity to poison oak? Probably had more babies than the guy who didn't have it, and so now that gene is more common. Like, it's always just some existing variant is more successful, has more babies, that's evolution happening. So speaking of humans, here's an interesting one. Do you all realize that humans are still evolving? But who's having the most babies now? Well, as a regional average on the planet, it is the northeast corner of India, where women have an average of about 13 children per woman. Average, average, average. So if that trend continues, humans are evolving to be more Northeast Indian. That's not necessarily because they are the smartest or the most successful at business or the best at arts and crafts or really good at reality television / presidential skills. It doesn't measure success anymore because success has now been decoupled from reproductive success. That's a new thing. Hello, homie.
Your clock's all fucking. You know that?
Yeah. Oh, we're not going to water until Friday. But I'll turn it off now. It's about time. Okay. Isn't that weird that we're evolving to be more Indian now? Do you realize that people that we would consider to be more successful today, like wealthy, don't necessarily have a lot of children? So if there were genetic traits that made you successful, they don't necessarily get passed on preferentially anymore. We're evolving, but we're not necessarily adapting anymore. Interesting obstacle. Anything about evolution that you want to ask me? By coincidence, and in case anyone's curious, this is actually what I studied at university, the evolution of behaviors, specifically reproductive behaviors. So if you want to talk about evolution, this is definitely my wheelhouse. We can definitely talk about this. Anybody curious about anything in evolution? Yeah.
I was gonna say, so the overall human population you're saying is getting more northeast Indian or whatever.
That's the place where our genes are becoming more common.
Right, rapidly produced. But isn't it true that like humans would also split into different species depending on like geographic, separation?
It's amazing that there's no genetic foundation for race.
Mm-hmm.
We have like what you might call color variants among humans, but that's really, really far from being genetically isolated. There is more genetic diversity within a population of humans than on average between populations of humans. So there's no genetic foundation for race. We're all one species. We are not sub-specifying. As a matter of fact, there's so much cross-pollination among humans that it would take a long period of isolation to divide us into different species. Very long period because we have a really big genotype. Can you turn off the water down below, please? Yeah.
Are humans kind of like homogenized in
2 sets of teeth. Yes.
travel?
Yes. 2 sets of teeth. That run our rows, the garden water irrigation rows. Turn off the
Like
water.
by where it sprinkles all over them?
Yes. According to the
Just
greenhouse.
that?
Yes. There's 2 separate ones right there.
Oh, okay, got it.
You could argue that, but basically what it is that we're just blending our colors. Genetically, we've always been one species, and so we remain one species. But we are losing variation. Redheads are going extinct. Do you guys realize that redhead is like a double recessive gene? So when redheads mate with other color types in humans, the redhead is very unlikely to come out. Are either of your parents redheads? Trip out. You're definitely redhead, right?
What?
You're definitely redhead, right?
I think so.
Like that's not a fake hair color? Anybody want to ask me anything about number 10 in evolution before I move on to other study goals? Number 12 then. If a niche is the way that a species makes a living inside of an ecosystem, we often say that 2 species cannot share one niche. One will eventually outcompete the other. That's the competitive exclusion principle. That in a niche, if you're truly sharing it, Sooner or later, the loser's going to have less babies until they disappear from that niche. Competition costs for everybody, so the other alternative is to split that niche by specializing. Check this out. Number 14. When people looked at those cabinets of curiosities, they started to notice patterns. Like, wow, this type of flower is only found on this one continent. Or, wow, this type of lizard is only found on that one continent. The chameleons with the independent moving eyes and the coily tails, those are only found in Africa. The iguanids with like the keel of flexible rubbery spines on their back are only found in the Americas. And so we notice these patterns of life on the map, biogeography. And there was some dude named Wallace, which named the realms of animals. And there was this other dude named something else who named the whatever you call them for vegetation. These were both attempts to map diversity in early biogeography. People from Europe studying the distribution of stuff around the planet. You've seen your biomes. But imagine what a mystery it was back in the day when people found an island where all the mammals, instead of having a uterus, have a pouch. Anybody know what we call those? Marsupials. And in case you hadn't heard this, the marsupial comes out of mom about the size of a small grain of rice. Mom doesn't even know it. No childbirth event. Mom just trickles little fetus rice grains throughout her life. It's a passive process, usually happens while she's sleeping or walking around. That little tiny baby has very, very limited development, but they do have little claws. So they climb mama's fur, follow their nose, dive into the pouch, and they finish growing up in the pouch, called marsupials. Isn't that weird?
What if it like fell out?
They do all the time.
Oh, but there's a lot of them.
But there's a lot of them.
Okay.
What if
You
a
know.
new one tries to come in and there's already a brother
They
or
can
a
share, there's a
sister?
whole bunch of nipples in there. Yep. So you've probably seen like the kangaroo with like the little joey poking out of the pouch. It's like a super iconic image.
Yeah, you only see one though.
I don't know how that works. I don't know, dude.
So what if there's a whole bunch of them?
Do I look like I know what I'm talking about? Look at me, for God's sake.
There's that one thing of the Australian guy punching the kangaroo. To save the dog.
Oh, no.
I haven't seen that, but I do know that kangaroos used to live on the road boxing because they're really good at punching. So people used to like box kangaroos, like touring like knuckle fights. Like, no, really, like people like went to Australia, like, oh, this would be great. I bet you I can take this back to Ireland, take it to the pubs, and we'll all drink and watch fight all of the bare knuckle dorks. And so like kangaroos came to Europe to fight bare knuckle drunk exhibition matches. All right. Imagine when you're making these maps of diversity and you find that there's this one island where the mammals don't have a uterus. You start cutting open all of those carcasses that are brought over, and you find these little tiny babies living in that little tiny pouch. Now we know them all to be marsupials. Imagine way back then, before the internet and stuff, trying to explain this pattern of life. You all understand how this happened, right? Everybody know how this happened? Does anybody know how this happened? How did this happen? How do we have an island full of marsupials?
It's isolated from the rest of Eurasia.
It's isolated from everything because it's an island. It's far away island. Raise your hand if you've heard of Gondwana land. Pangaea?
Oh.
Pangaea? Watch this. Imagine a time when all the continents were stuck together and they were covered with marsupials. One piece broke off first. Australia. Technically, Asia broke off first, but then it got stuck again. So, the first one to break off and stay broken off was Australia. The whole planet's still covered in marsupials. The remainder of Pangaea and Australia. Australia keeps drifting away at a tectonic rate of movement, while on the remaining chunks of dirt, a new mammal evolves. This one keeps the babies on the inside, like a sealed off pouch. Don't have to make 40,000 disposable grains of rice. You just got to make one really good quality one. And drop it at that last moment when you can barely squeeze it out of the, the baby, please. Turns out that being a placental mammal was a winning strategy. Placental mammals evolved to replace all of the marsupial mammals across that entire landmass that broke out into our current map, except for Australia, which never encountered placental mammals. They're just like mammals 1.0, and you and I are mammals 2.0. Isn't that interesting? Trip out on this, though. There was a mammal in the marsupial version. Now there's a placental version of basically every one of those. So there used to be a marsupial version of wolves and a marsupial version of what we call rabbits and a marsupial version of like a groundhog. Flying squirrels. That's a pretty obscure way to make a living, right? A squirrel that lives in trees that flies out with a wingsuit. There was a flying phalanger in Australia, like, I think they're still around actually, yeah.
So generally when it says how is animal and plant diversity distributed in biogeographical zones, it's by common characteristics, right?
Yeah.
Okay.
And there are distinct phylogenetic patterns. So related organisms on different land masses. Because of this thing we just said about the evolution and geography and plate tectonics. Hey, check this out. There was a marsupial anteater. Like, you think of all the wacky placental mammals we've got? Well, there was a marsupial version of all of those. So my question for you is this. How do such different types of mammals evolve into being almost basically the exact same ways to make a living? How do you get such similarity evolving from different starting points? You should know this.
Similar environments.
Similar environments do what? Similar environments apply similar pressures to select similar adaptations. It's called convergent evolution. Starting from a different place, species evolve similar adaptations because they're in a similar niche. It's called convergent evolution. You have to know this one. Yeah.
Does that mean that if there's like another Earth-like planet, similar creatures to our planet here could have evolved?
Well, keep in mind that these are still related.
Mm-hmm.
So from a common starting point, it's likely that you would come up with similar solutions to similar problems. If you're talking about a planet similar to Earth, where early life was genetically identical, then yeah, they would probably evolve similar directional adaptation pathways.
Mm-hmm.
But if life evolved independently on those two Earths, then there's no reason to expect them to be similar. I got a cool example for you. Check this out. Dolphin, dinosaur. Look at how similar they are. They both have the beak, they both have the eyes, the hole to breathe in, the eyebrow, the forehead thing. They both have the little teeth curved back. They both have fins in the same place. They both have basically the same shape and the same tail. They both do the same types of hunting in water, so they're going to look and be shaped very similarly. Because you know you converge on the same answers when you're responding to the same selective pressures. Is that enough evolutionary language for one sentence? Here's one crazy thing. The dinosaur was like longer than his classroom. Because their food was bigger, they obviously evolved to be bigger. So they've converged on basically the same niche, but at a time when the planet had a different amount of oxygen in the water, so the life was a different scale. Isn't that neat? Check out these snakes. One evolved in Asia, one evolved in South America. They both eat baby birds out of their nests at night high up in the canopy of tropical rainforest. So they both have a cat slit pupil because that makes sense for hunting in the dark. They both have heat sensing pits because that makes sense trying to find little baby birds. They both coil up in the same way because that makes sense living in the trees. They're both green because they're both in the tropics. They both have these mysterious multicolored babies that nobody understands how that's adaptive, but apparently it must because they both have them. And strangely, their closest common ancestor was some primitive, giant, terrestrial constrictor swamp snake.
How big is it?
Very, very large. Bigger than today's African rock python.
Well, I don't know.
Indian rock
I don't know how
python.
big that is.
Biggest snake, biggest snake. Bigger than today's biggest snake.
I don't know how today.
I don't know either. It's very big, like a log.
Log's very.
I will
Was it
squeeze
like
your
a-
last breath
was it like
out
a
with these
redwood?
two hands, young man.
Perfect.
We got our convergent evolution. Everybody knows what an ecological island is because nobody asked me. The only thing that I've got left over for Friday is to talk about diversity. Genetic diversity, genetic bottleneck, and genetic risk. That's a little bit too much talking to fit in today. So I think we might get a couple of minutes of chilling. Or should I try to do that study goal and call it good?
Just wait, it's like 8 minutes left.
It's going to be tough to get it in 8 minutes. Can you turn off our stream, please?
Stop this.